Okay, well, start off again. Okay, I am Peter. I am the community advocate at the Open Policy Agent project. I get to play with Open Policy Agent when it gets connected to all these tools like Terraform. I get to build things and try things. And so a little about me, community builder. I spend most of my time working in open source and gathering people together to work on open source tools. And so let's kick it off with the tools that we're going to be working with today. Right, and so name of this talk, Open Policy Agent and Terraform Cloud. So those are going to be the two tools on the right here. We're going to they're going to be doing the heavy lifting of this demo, right? And so I'm going to imagine that everyone watching Hashi Talks is pretty familiar with what Terraform does and what Terraform Cloud is. I won't really dive into what they do. We're just gonna dive into the tool set. I will explain a little bit about Open Policy Agent, it being a general purpose policy engine, and then StyradDAS, a control plane on top, which we will use for a bit in the demo as well. So to start off, OPA, or for Open Policy Agent, is a general purpose policy engine. This means that it's going to work across your stack. It's going to work with all the tools that you are going to put into your technology stack. And so that's going to be everything from your application layer all the way down to your infrastructure, right? And so how this is going to work is it's a decoupled model. And so I can actually, on this next slide here, a little better, this visual's a little bit better to kind of explain this, right? So it's a decoupled decision model where essentially you are decoupling the policy decision from the service that's using it. So in this case, we have that service positioned right above OPA in this diagram. And so you can imagine for this talk, Terraform is going to be that service. It's going to be asking questions. It's going to bundle up the question and ask OPA. It's going to send that query over to OPA as a JSON object. That JSON object is going to contain any parameters of the request, and then OPA is going to compare that query to the policies that it has defined and any data that is also provided with it. Once it's made that comparison, it's going to know essentially what the response is going to be and ship that back to the service that made the request as a new JSON object. And so with that, fairly simple. And then on top of that, what we're going to have is StyradDAS. And so StyradDAS is a control plane for OPA. It hooks into the management APIs for Open Policy Agent. So essentially, it's going to allow you to do things like write policies and then ship them directly to OPA, or take in or to take out any of the decision logging and centralize that in one spot if you want to do any monitoring on what the OPAs look like. And so with this approach, we're actually going to look at running OPA a couple different ways in Terraform Cloud. One is going to be the native way, and then one is going to be through their run task feature. And so let's pull up a quick diagram here, right? And so this is just a very simple diagram of Terraform Cloud. In this diagram, essentially, you are on the left here is Terraform Cloud, and then imagine that you are building whatever resources you want. You're going to run that execution, and then when that execution, or when that plan is created, it's going to get to this run task phase. And at that run task phase, this is when it's going to make the call out to OPA. If you have this is either going to be where it's going to ask the policy set that's within Terraform Cloud, or you can use this run task to do the call out to StyradDAS. And then we're gonna look at both of these approaches, right? And so here we can see this diagram, which shows where that run task is going to live, right? So with Open Policy Agent, essentially, Open Policy Agent is going to be looking at the plan that is generated by Terraform Cloud, which is why it comes directly after the plan phase. Once that plan is generated and we know what the diff or created resources are going to be, we can actually convert that to that JSON object that Open Policy Agent is looking for, and then we can send the call out to Open Policy Agent. And so here we can see it's kind of just like a webhook model here. And so with that, oh wait, no, hold on, a couple more slides here. Yeah, so let's talk a little bit about the policy that we're going to be enforcing today, right? And so you can excuse my very elementary drawing here. Drawing is not my best skill set, but what we're going to be creating, we're just going to be creating a VPC. Inside of that networking VPC, there's going to be an EC2 instance acting as like a jump host or a bastion or whatever you want to call it, and then we're going to have a couple of security group rules. One security group rule coming in on port 22 for SSH, and then one security group rule going out on 0.0.0.0/0. So just like a egress all allowed. And so this is going to be the Terraform resources we're creating. Now let's look at the policies that we're going to be building, right? And so on the left-hand side here, this is just trying to state the policy in as simple English as possible, right? When you're talking about policies, typically you want to you want to start with as simple English as possible, right? So like what is the business logic of this policy, right? And so we have here no public ingresses, no deploys on Thursdays, and then except admins, right? And so very simple. And then maybe you want to define those a little bit further. You want to dive into like, what do these mean? It's like, oh, no public ingresses. Okay, more specifically, we're not going to allow that that all zero IP address. We're going to be looking for, we're going to allow private subnets instead. And then the no deploys on Thursdays. We want to check what the current date is, and then deny anything if it is on a Thursday, which it is today. So hopefully that all works out as I expect it to. And then last one here, last rule, right, is just a allow admins rule. So kind of if something like that happens, we want to be able to get past it. And so with that, we've defined the resources we're creating, the policies that we're creating, and the tool sets that we are going to use today. So let's hop on over to our demo. And so with this, we're going to jump into Terraform Cloud here. I have my organization here. Inside of this organization, I have a workspace called OpenTF. Inside of this OpenTF workspace, actually, let's back out a little bit. So let's first start within our organizations. Policies can be defined by organization or by workspace. And so let's create a policy set real quick. And I'm just going to do this directly in the web browser here. Obviously, best practices is always to connect this to some sort of Git repository to make sure that you're backing up all of your policies. And so with this policy set, right, this policy set is going to contain, this policy set is going to define where these policies are going to be applied. With this policy set, I'm just going to do all workspaces, just to make this very simple. Apply policies to all workspaces as a description. Select all workspaces, connect policy set. All right, that now exists. And so now we know where our policies will be applied. Now let's create our first policy here. Right, and so we're going to be choosing Open Policy Agent. And so it pretty much plugs in exactly the same as Sentinel does, but we're going to be using now the Rego coding language to define what our policies look like. And so with this policy, I'm going to call this just deny, gotta spell right, public ingress, description, deny 0.0.0.0/0. And we're going to make this mandatory. We're going to say stop anything if it does, if it encounters an error, right? And so with this, with the Rego code, we always start with a package. I'm going to get back to the query in a second. It'll make more sense after I define the package. So a package in Rego is just a naming convention of how your policies are grouped together. So in this package, I have we're in the Terraform package, we're in policies, and we're in public ingress. So this is one way you could separate your policies. And so you just have a set of public ingress policies. The next thing I'm going to do here is an import. Input.plan as TF plan. This is basically converting the plan that's being sent to OPA in the input and naming it as TF plan just to make the rule a little more legible. Then we're going to make a deny rule here. And inside of this deny rule, we're going to pass it a message. This message is going to be what we want it to contain if all these parameters are true. So we're going to set a variable. We're going to look for that TF plan. We're going to look in that TF plan, look for resource changes. And then this last one is kind of cycle through all of those resource changes. So anything that is changing, we want to look at it. And it's going to be assigned to that variable R. And then we're going to look at that variable. And we're going to look inside of that object for type. And if that equals this. And so if the type is an AWS security group, then we continue on and keep checking it. And now we're going to look inside of that object one more time now that we know that it is an AWS security group. And we're going to look for change after ingress. And we're going to cycle through each of the ingresses. And then we're going to check the CIDR blocks here. And inside of these CIDR blocks, we are going to see if it equals that 0.0.0.0/0. And then we're going to provide that message, right? So now we said, like, if all these things are true, we want to deny with the message. And so this is going to be that message that we're going to provide back. And so we'll just a quick sprintf. Do this here. So with this, the very first thing here is going to be a variable that we're going to want to pass back to the object. Say what the problem is. And okay, so now we have that, and what we want to pass back in here is just the address, so we know which one caused this problem. So now we have our regular policy here to deny any security groups inside of the Terraform plan that has an open ingress. And so the next thing we want to do is provide a query. And so basically, this query is going to be look inside of this package name, and then inside of the package name, all the way down into the rule head, which is deny. And so that's how we know exactly where it's going. And so with that, we have our policy defined. Now let's assign it to a set. We're going to assign it to the all workspaces set that we created just a moment ago. Name is invalid. Spaces. Okay. I think that looks good. There we go. That looks good. Our policy set is applied. Let's hop on over to Cloud 9 here. I have my Terraform files up here in the main file. We're just running one network module that's going to create the resources that I defined earlier. So let's look inside of this module. Inside this module, we'll see that spinning up standard VPC module just to create that structure. Then here is the AWS instance that we're creating. It's Amazon Linux. Nothing too special there. And then the part that we actually care about here is this security group that's going to allow these rules. And so with that, one thing that I have already done here is I've logged in from the terminal here into Terraform Cloud. You will have to connect your tools together in order to do this. And so now that I'm running Terraform Apply, you can see that it's reaching out to Terraform Cloud. So we can hop back over to Terraform Cloud and actually watch that run. So here we can see that it triggered, it remotely triggered or triggered via CLI here. We can see that it triggered this run from the CLI. And so as it's creating that that Terraform plan, a same plan populates here. So this will take just a second. It's not that big of a resource plan. And so now we can see that the plan has been created, and we can see that the policy failed. One thing that I have noticed is that inside of your CLI, it doesn't actually feed back the policy failed that you see in Terraform Cloud. And so if you get stuck on cloud or cost estimation, that could mean that a policy failed, and it's not exactly clear. But going over to Terraform Cloud, we can see exactly what did fail here. And so now that we see what failed, we can see that deny public ingress. So we can discard this run, right? Go back here. It should get the cancel signal. That gets canceled out, right? We can change. We can change the CIDR block for that ingress to something private, and just anything other than that open CIDR block that we had before. This starts up a new run, reaches back out to Terraform Cloud. We could see here, new plan has been started. And so this should take just another second here. Plan has been created, and processing the policies now. And we see that now that we have this, now that we have the correct CIDR block, that the policy actually, or the policy allows these resources to be created. I'm not going to create this because we don't actually need to see that. We just want to see that something is going to be blocked. And so I'm going to switch these CIDR blocks back, and I'm going to show now another way to do this. And so inside of my Terraform org here, I'm going to go back up to my org settings, policy sets. I'm going to delete this for now so we don't have overlapping policies here. So the policy set has been removed. So this one is no longer applied now. So what we're going to be doing is now we're going to be using the run task version of Open Policy Agent inside of Terraform Cloud. And so I've already gone through the setup of this just because we don't have a ton of time, and I didn't want all of the time to be taken up watching me just generate tokens and stuff. And so, but I will walk you through the parameters real quick. Inside Terraform Cloud, we have an organization token. This organization token allows you to make changes inside of Terraform Cloud. And so we provide that to Styra DAS here. And inside Styra DAS, we provide that token here. And then we connect it, or we map one of our system types specifically to a workspace. And so I'm mapping this HashiTalk system type. And so a system type is essentially just a grouping of policies. And so this is a grouping of Terraform policies that are now mapped specifically to my OpenTF workspace. And so now that these are connected, right, this ID right here, ending in capital LDJ, will match, oops, let's see, back to our workspaces, projects and workspace. Right, that's going to match our workspace here, capital LDJ. So that's how we know which workspace is mapped to which system type within Styra DAS. And so these two are connected now. So let's actually try to do a very similar policy. And so how policies are grouped here, we have this policy folder, and inside this policy folder, we have the different types of clouds. We have AWS, Azure, GCP. And so inside of that, we have groupings of where those rules actually, or where those rules exist. And so security groups are a subgroup of EC2. Oops. And so let's add a new rule. And so one of the nice things about Styra DAS was a bunch of pre-built rules. And so this is that same rule we wrote by hand, restrict ingresses from public IPs. So that's in there. We just hit enforce. We could publish it. publish these changes. So now this Rego policy is being pushed over to Open Policy Agent, right? So now Open Policy Agent is going to have this policy inside of its memory, waiting to check it out. And so when we apply this again, right, starts up that run inside of Terraform Cloud. Terraform Cloud is going to start running this new build. And so now instead of running the policy directly inside of Terraform Cloud, it's going to reach out to Styra DAS and do that and do the run task to evaluate that policy. So here we see that policy has failed. And so the nice thing here is it actually feeds back directly into the CLI, and so you can kind of see where the failure happened without having to jump back. Or if you are just in the CLI, you don't have to jump out of the CLI, go check the web GUI to see that has happened, right? And so we see this has failed. We can see that it stopped the run, and so now we can, right, basically do the same thing we did last time. Rerun this with a private ingress block. This private ingress block, we can see that this policy is going to, or this policy is going to allow this private block. And while that's running, I'm actually going to pop back over here and check out the decision log and kind of show what that policy did, right? And so here we see a bunch of runs that I've done beforehand, but this very last one is the one that I'm interested in, right? This is the one that we just ran, and this one basically says that there was that failure. We see that this security group module, security group bastion, has an unapproved ingress from that 0000/0. And so inside of here, we're basically looking at the full input that Terraform Cloud sent over. Terraform Cloud sent over the change log for what it wanted to create. And so that's just in here. This is quite a long output, so I won't go through it too far, but it will just show, like, near the bottom here is we can actually see the results that were created by OPA, and we can see that the allowed equals false and those error messages. And so we can hop back over to our terminal now, and we can see that is passed. We can see the policy is passed. It's asking us to create these resources, giving us cost estimation. Once again, I'm going to deny that. And so now that that's done, let's try to just write a policy from scratch now. And so back here, right, let's go back under these policies. Let's add a policy. And remember, each of the clouds has a defined grouping. So there's defined groupings. So we want Terraform Cloud here. And then the resource type here is run. And then so we need to name this file something. Rules.rego is as good as any. So now that we have this rules.rego, let's try to actually define a new rule here. And so I'm just going to drop this directly to enforce. Typically, you would do something like monitor to see exactly what's going on, see if it's going to be affected or if it's going to affect any changes or cause problems. But today we're just going to be going right to enforce mode. And so no deployments allowed on Thursdays because today is Thursday. And so let's get today's date, or let's get the date of today. And so today is going to be time.weekday. And then we're going to feed in time.now to check the current time. And so now that we have that, we know what today is going to be. And now let's actually check that if today is equal to, there we go. All right, and almost messed it up there. And so if today is equal to Thursday, we want to send back the decision that cloud is false. And then we also want to be explanatory, so we'll pass back a message, and that message is going to be what we defined above. And so here we go. Let's just direct publish here. Once again, if you're doing good best practices, you would save this all in a GitHub repository. I'm shipping this directly to OPA for simplicity of this demo. Cool. And so just doing a little preview here, kind of making sure that there's no errors in my Rego code here. And so now let's run this policy one more time. Right. So that is spinning up. We can go one more time, check it here. Spinning that, the plan is spinning up. Should be the same plan that we see here in our terminal window. Cool. And so here we see this failure. We can see the failure here, but we don't necessarily see exactly why it failed. So with this one, right, we might want to hit details. With the decisions, sometimes it takes about a minute for them to populate. So while that's happening, while that's populating, I'm going to go back over to our rule set because I already know what the problem is. We can kind of skip around this. And let's just actually make a way around this, right? Let's say allowed users. And I'm going to say that I'm an allowed user, right? That's my username. And so now let's say that, let's add that into here. And so how we're going to do this, we're going to use the not keyword. Not is going to negate the next thing. And so actually, wait, let's call this admins. That's what I meant to call this. So now we have this new rule here. So not admins is checking for the username here against the last result. So I'm going to publish this. Let's go back over to our decision log here, and we can see it has populated. And so we see that the rule we expected, no deployments on Thursday, was indeed the one that triggered this policy. And so, but now we have our new policy up, which is allowing very specifically my username, which we can see here is Peter ONeill Jr. And so with that, I think this is our last run here. And so last time you have to see this thing spin up. Hopefully it works as expected, and the demo gods are on my side today. Cool. And just like that, we have written from scratch our own Rego policies and enforce them within Terraform Cloud. And so just doing a little recap here, right? Things that we learned that Open Policy Agent as a general purpose policy engine can be used with Terraform or any other tools in your tech stack. We've learned policies are defined in Rego, the language we were just coding in, which is a purpose-built policy language, right? This comes as kind of the hand-in-hand companion with Open Policy Agent. And then we learned how to add an open policy directly in Terraform Cloud using their policy set features. And then we also learned how to use the Terraform Cloud run task feature in order to call out to enforce OPA and Rego policies. Cool. And with that, I'm not sure how much time we have left for questions. I think we have a few minutes. So if people do have questions, I'll be around. And I want to say thanks. If you want to connect with me, you can use my QR code here to add me on Twitter. If you want to give this a try, you can scan the other QR code there.